All right, so now we are going to learn how to use MemBrain for our binary segmentation of, no. Okay, so now we have processed our tomogram through ISONET and we have denoised it and it is ready for segmentation. The first program we use for segmentation is called MemBrain. It is a program developed by a lab, and it does a really, really excellent job at segmenting our membranes and membrane-bound organelles. So I'm going to show you how to do that. This is assuming you've already installed the MemBrain program from the GitHub and already created your Conda environment for MemBrain. So let's take a look at the files we're going to be working with. So I'm going to open a new window into my home right here. The files I'm going to be working with are in this directory Rlan. I have my cryo-EM directory for all my cryo-EM data, and I have two folders, my MemBrain inputs and my MemBrain outputs. So I'm going to go to my MemBrain input, and here is the tomogram I'm going to be working with. This is the tomogram that we had as our output from ISONET. That's why we see the deconv at the side. So up here is my path to my input tomogram. One thing I'll also show you is on my home, you can see this MemBrain seg. We've downloaded it from the GitHub, and so we can see it here. We have the models, and this is the model that we'll be using, MemBrain seg v10. Okay, so first thing I'm going to do is I'm going to open a terminal up, and I'm going to navigate to my input directory. So Rlan cryo-EM data membrane inputs. Great. The blue shows up. We're now in that working directory. I then want to make sure I activate my membrane environment. So we have all the proper dependencies and we are not messing with any of the installations on the actual computer. Now, membrane is as simple as copy pasting a command. The command template is in the guide document. I have it copied and ready for me to go on my side. So that's open right here. I'm just going to go ahead and copy this and paste it in, and I'll walk you through this, everything we see. So membrane segment is the command. Our tomogram path we saw was from the home to Rlan to cryo-EM to membrane inputs to position 5B0602 decon. The CKPT path is our model, and we saw that model in our home directory leading to this model. The output folder is the one that membrane is actually going to generate. So I want it to be in this pathway in the membrane inputs, and I want it to create a specific folder for position 5V0602. And I also want to add this flag for store probabilities so that it gets stored. All I need to do now is hit enter. It'll come up and tell you that you are segmenting the tomogram, and it'll tell you it can take several minutes. You'll note that it says it's going to perform an 8-fold test time augmentation. That means it's going to segment around 8 times, and you'll see this bar come up around 8 times. Generally, depending on your CPU compute power, it'll take between 3 to 5 minutes per tomogram. I'm not going to make you sit here through the whole download of this, so I will see you after this completes. All right, and we're back. We can see that it says membrane has finished segmenting your tomogram and the command is completed. So now we can safely close our terminal up and let's go check out our files. I'm going to navigate to my Rlan cryo-EM data membrane outputs, and we can see our output folder has been generated. And if I open it, we have our two output files. So the top one is going to be our binary mask, and this is going to be a grayscale mask. Let's check out what they look like. So I'm going to open a terminal here, and I'm going to use the 3D mod command to visualize them. 3D mod position 5B. Let's look at the binary mask first. So it's popped up here, and this is what it looks like. We can see this really, really rich ER network going through, and you can see it's done a fantastic job at segmenting all of the membrane. Seems to be some cool autophagosome-like structure here, a real ton of ER and vesicles all around the place. Should be really fun to segment. And also 3D mod that grayscale and check out what that looks like. And now we can see background is more grayish and we have a whitish signal. So this will actually be the file that we import into Amira for our segmentation. And that's it. That's how to use MemBrain. You have everything ready now. There will be an extra part on running a dash script for MemBrain on multiple tomograms. So I'll get to that in just a moment. Okay, so like mentioned before, you can also run a shell script that batches over and loops through multiple tomograms if you have many that you want to run membrane seg on. Sometimes you're working with a data set and you want to run membrane seg and segment 20, 30, 50, 100 tomograms. Instead of using these commands and running it manually every single time, you can actually run a script to loop through. So we're working in that same directory, home, Rely cryo-EM data. I've now added some new files to membrane input. So let's take a look. We still have that position 5B that we were looking at, but I've also added 16B and 17B. And we also have this run membrane batch.sh, the shell script, which we can also download from the GitHub. So let's actually take a look at what this script does quickly. So you can see first, it activates the Conda environment. We specify already what the input, output, and model directories are. And essentially you loop through all tomograms that match this naming format. This is why it's so important to have the same name, a same pattern. So everything that follows this pattern will be looped through. Each one of them is going to get their unique output folder and it will run membrane on it. So when you run the script, you don't even need to launch the Conda environment. The only thing you need to make sure is that this script is executable. So you do chmod plus x and then your script name. Okay. Now you hit period slash and you can type in your shell script and enter. So we can see it's starting to run membrane on 16B first. Again, I won't make you sit through this, so I'll wait till this finishes, come back, and I'll show you how the terminal output looks where it runs through every single position. All right, so we can now see that all tomograms have been processed and the command is finished running. If I scroll up through the terminal, I can see it starts running through segmentation 16B, says finished 16B, starts running on 17B, finish 17B, and then it starts running on 5B, finishes 5B. So we've seen that it is now run through all of it with just one command. Let's go back to our membrane outputs directory, and now we can see each of these positions have their own respective folders. So 5B, I have segmented and scores file, 16B, segmented and scores file, 17B, segmented and scores file. So when you're working with large data sets, it's super, super useful to have this script help you out, which again, you can download straight from the GitHub. And that's how to use MemBrain. You're now a master. Thanks so much. See you next time.